Hey everyone, and welcome! Today we are going to pull back the curtain on one of the coolest tools in data visualization, the Boxplot. I know, it might look a little weird at first, but trust me, by the end of this, you'll see just how powerful it is for understanding the story hidden inside a bunch of numbers. So let me ask you a question. Imagine you have test scores from two different classes, just two big lists of numbers. How do you figure out quickly which class did better, or which class was more consistent? I mean, staring at dozens of numbers is just confusing, right? But what if? What if there was a way to see the answer, almost instantly, in a single picture? So here's our plan for today. We'll start with that quick visual answer. Then we'll decode what every little part of a box plot actually means. After that, and this is the fun part, we're going to build one from scratch so you can see exactly how it works. Then we'll unlock its real superpower, comparing groups. And finally, we'll see why this might just become your new favorite tool for looking at data. All right, so how do you compare two whole classes in just 5 seconds? Well, the answer is the Boxplot. It's this simple, clean chart that just cuts through all the noise of the individual numbers to show you the big picture, the real story your data is trying to tell you. Okay, so what in the world are we even looking at here? When you first see a Boxplot, what you're seeing is a visual summary of an entire list of numbers. So let's break it down piece by piece and figure out what it all means. At its core, a boxplot is really just a picture of 5 key numbers that describe your data. The word standardized is important here. It means once you learn how to read one of these, you can read all of them. It's kind of like a universal language for data. And the recipe for that picture is what we call the 5-number summary. I like to think of it as the data's DNA. If you have these 5 numbers, you have everything, and I mean everything. You need to understand the core of your data and to draw its boxplot. So what are these 5 magic numbers? Well, we start with the easy ones, the lowest value, which is the minimum, and the highest value, the maximum. Then, in between those, we have 3 other points that chop our data up into 4 equal quarters. We call them the first quartile, the median, and the third quartile. And here's how that all translates into the picture you see. That rectangle, the box, that's the middle 50% of all your data. It's the core, the bulk of your group. The line inside the box, that's the median, the exact middle point. And those lines sticking out, the whiskers, they show you the range of the rest of your typical data, all the way from the lowest to the highest scores.
Okay, theory is one thing, but actually doing it is another. Let's make this real. We're going to take a simple list of numbers and turn it into a boxplot step by step. You'll see, it's not that hard.
Let's start with some raw data. Here are 10 test scores from a class. Right now, it's just a jumble of numbers, right? It's pretty hard to get a real sense of how the class did just by looking at this. Okay, step 1, and this is the most important step, so listen up. You have to put the data in order, smallest number to largest. This is totally non-negotiable. Every single calculation we do from here on out depends on this list being perfectly ordered. Now, let's find the median. This is also called Q2, and is the value that sits right in the middle. Now, since we have 10 scores, an even number, there isn't one single number smack in the middle. So to find that true center, we just take the 2 middle values, in our case the 5th and 6th ones, and find their average. And boom, there it is. Our median is 80. This one number perfectly splits our data set right down the middle. Exactly half the students scored below an 80, and the other half scored above it. This is our 50th percentile, and it's going to be the line inside our box. So what's next? Well, we basically just do that exact same thing again, but this time on the 2 halves of data we just created. We find the median of the lower half to get our first quartile, or Q1, and then we find the median of the upper half to get our third quartile, Q3. Okay, so that lower half has 5 numbers. Finding the middle of 5 is easy, right? It's just the third number in the list. So our Q1 is 71. The upper half also has 5 numbers, and its middle value is 88. That's our Q3. See? These 2 numbers will become the edges of our box. And just like that, we have our complete blueprint. The minimum is 51, Q1 is 71, the median is 80, Q3 is 88, and the maximum is 95. These 5 numbers tell the whole story of our data structure, and they are literally all we need to draw the plot. So building one is pretty cool, but now we get to the really good stuff. This is where the Boxplot goes from being a neat little summary to an absolutely essential tool, comparing different groups in an instant. Let's set up a classic scenario. A professor teaches the same class twice, once in the morning and once in the evening. And they're curious, is there any real difference in how the students in these two classes are performing? So here are the 5 number summaries for both classes. That morning class is the one we just built together. And we've also got the summary for the evening class. Now, you could just stare at this table of numbers for a while, but it's still kind of hard to quickly see the full story, isn't it? But the second we turn these numbers into 2 box plots and put them right next to each other, the story just jumps off the page. So let's be data detectives for a minute. What are the key differences we can spot right away that tell us about these two classes? Okay, the very first thing your eyes probably go to is that line inside the box, the median. Notice how the median for the evening class, at 81, is just a little bit higher than the morning class's 80. This is our first clue. It tells us that the typical student in the evening class did slightly better. It's a small difference, sure, but it's where our investigation starts. Now, look at the size of the boxes themselves. This is a huge deal. The box shows the interquartile range, the IQR, which is just a fancy way of saying where the middle 50% of the students scored. For the morning class, the box goes from 71 to 88. That's a 17-point spread. But the evening class, their box is way wider, from 75 to 95, a 20-point spread. This tells us that the evening class scores were much more variable, less consistent. The morning class was more predictable, but the evening class had a wider range of performance right in the middle of the pack. And finally, let's look at the whiskers, which tell us about the extremes. The evening class had someone get a perfect 100, and their lowest score was a 65. The morning class, on the other hand, topped out at 95, but its lowest score was all the way down at 51. So this adds another layer to the story. The entire evening class seems shifted higher up. Even their lowest score was better. But the morning class actually had a much bigger gap between its very best student and its very worst student. And this really gets to the whole point. Yeah, a box plot might hide some of the tiny little details you'd see in, say, a histogram, but its true genius is revealing these complex, multi-layered stories in a single glance. In just a few seconds, we learned about typical performance, consistency, and the range of scores for 2 entire groups. That's its superpower. All right, let's bring it all home and recap what makes the box plot such a critical part of your analytical toolkit. So, when should you reach for a box plot? Well, it boils down to 3 main things. First, you get a super fast visual summary of your data's center and spread. Second, it is hands down one of the best ways to compare multiple groups at once. And third, while we didn't have any in our data, box plots make it incredibly easy to spot outliers, those data points that are way, way different from everything else. It really is a powerful summary in one tiny picture. So now you have the tools to make and understand these awesome charts. My final question for you is this. What hidden story is just waiting out there for you to find? Could you compare housing prices in 2 different neighborhoods? The stats for 2 of your favorite athletes? The world is absolutely full of data, and now you have a brand new lens to see it through. Thanks for joining me.